Imagine, for just a second, the physical reality of a drone flying this incredibly critical, highly sensitive mission.
Right, and we aren't talking about like a consumer quadcopter you buy at the store.
No, exactly. We are talking about a multi-million-dollar piece of aerospace engineering.
Yeah,
Maybe it's, miles above a hostile environment, or maybe navigating some unpredictable disaster zone where visibility is just absolute zero.
totally blind.
Right. And suddenly, deep within the fuselage, a sensor registers this massive, unexpected drop in fuel pressure.
Which is a worst case scenario.
The absolute worst. Now, if we rewind the clock just a few years to the recent past, that blinking red light on a control panel thousands of miles away meant one of two things.
Panic.
Yeah, pretty much. It meant a frantic, adrenaline-fueled scramble by a human operator staring at a screen, sweating, trying to manually calculate glide paths and wind shear.
In their head, basically.
Yeah, in real time. Or, let's be honest, far more likely, it meant a crashed piece of multi-million-dollar hardware and a completely failed mission.
Yep, that was the reality.
But today, the reality of 2026 is completely different. An autonomous artificial intelligence within that drone evaluates millions of multidimensional variables. I mean, altitude, atmospheric density, structural integrity, secondary objectives.
Well, in milliseconds.
Exactly. It instantly generates a dozen mission replan options. It seamlessly reassigns the primary objective to a secondary drone flying 50 miles away, and it commands the compromised unit to alter its aerodynamics and safely fly itself back to a designated recovery base.
And all of this happens in the span of, what, maybe 3 seconds?
3 seconds, with absolutely zero human input.
It's a profound paradigm shift in how we interact with technology.
It really is.
I mean, we have fundamentally removed the human being from the immediate loop of execution. We've elevated the human from the person pulling the levers to the architect who, designs the system that pulls its own lever.
That's a great way to put it.
And that drone is really just the physical, dramatic manifestation of a much deeper, kind of invisible revolution that is currently rewriting the rules of business, logistics, and data.
And that invisible revolution is exactly what we're getting into today. Welcome to episode 14.2026, Applied Data Mining. This is the 14th episode of this year's Bits and Bytes in Business podcast, but as always, we're treating this as a comprehensive deep dive into the source material.
So much to cover today.
Oh, absolutely. And really quickly, if you caught our last deep dive, episode 13.2026, where we talked about the ROI of soft skills in hard tech.
Which was a fantastic discussion, by the way.
Thanks. Yeah, it really set the stage for this.
Right.
Because today we are unpacking a massively detailed 2026 research briefing on applied data mining. We're exploring how the entire global industry has shifted away from human beings staring at historical charts, moving toward these autonomous, agentic AI systems that make decisions on the fly.
The agentic shift, it's huge.
It is. We're also going to map out the physical geography of this shift, exploring how the Dallas-Fort Worth area DFW has cemented itself as North America's undisputed tech capital.
The absolute epicenter right now.
For sure. And crucially, for anyone listening who wants to actually navigate this economy, we're looking at the specific academic blueprints. We'll examine how institutions, specifically using Tarleton State University's Dr. Sam Pack College of Business as our prime case study today, are actively training the humans who govern these machines.
Because the machines, no matter how advanced their neural networks become, they still require governance.
Right.
They require a strategic master who understands both the mathematics and the overarching business objectives.
Mm-hmm.
Without that governance, you don't really have an asset. You have an incredibly fast, highly automated liability.
A liability that can lose you millions in 3 seconds.
Exactly.
So I want to speak directly to you, the listener, right now. Whether you are an early career professional trying to figure out your next strategic move, a student looking at this rapidly changing landscape, or maybe you're a seasoned executive prepping for a massive, terrifying tech migration at your company, this deep dive is your shortcut.
Your survival guide, really.
Yeah. This is your guide to understanding both the underlying mechanics and the massive amounts of money driving this 2026 data revolution. And to make sure you never miss these vital strategic insights, take just a second early on here to like, subscribe, and share the show.
It really helps us out.
It does. Staying connected with us means you get a constant, reliable stream of these aha moments. We do the heavy lifting of synthesizing all this dense research so you can stay on the absolute cutting edge of business and tech.
And definitely don't forget to check out our YouTube channel, too, for access to course materials, videos, and other resources to keep you engaged with all this stuff.
Yes, the YouTube channel is packed with good stuff. Okay, let's unpack this briefing. We need to start by confronting the reality of enterprise data in 2026, because the very definition of the word analytics has fundamentally changed from what it was, say, a decade ago.
Oh, completely. To truly understand where we are standing today, we really have to look back at what we've decisively left behind.
Okay, lay it out for us.
Well, for decades, the absolute gold standard of business intelligence was what the industry called descriptive analytics.
Okay, descriptive analytics. That brings to mind like the classic pie chart in a PowerPoint presentation, the quarterly dashboard showing last month's sales figures.
Yeah, that is essentially what it was. It served as a retrospective accounting tool. I mean, it was incredibly useful for its time, don't get me wrong.
Right.
But its sole foundational function was to explain what had already happened.
It was pure hindsight.
Exactly. You gather the data from various systems, a team of analysts spent weeks cleaning it up, and they eventually built a static report that told the C-suite, why revenue dipped 3 months ago in the European market.
So it's basically like driving a car down the highway while exclusively staring into the rearview mirror.
That's a great way to think about it.
Like, you have a crystal clear view of the pothole you just hit, but you have absolutely no idea what's coming through the windshield.
That analogy captures the limitation perfectly. And if descriptive analytics is that rearview mirror, what we have deployed in 2026, what we call prescriptive analytics in agentic AI systems, is the self-driving steering wheel that actually swerves to avoid the crash before you even see the obstacle.
Oh, okay.
We have moved from historical hindsight to autonomous foresight in action. These modern systems aren't just forecasting future probabilities in a vacuum. They are independently suggesting, and in many critical enterprise use cases, directly executing the optimal course of action in real time.
I want to break down what that actually looks like for a normal person working at a company, because the term agentic AI can easily sound like a sci-fi movie trope,
Yeah,
where the computers lock the doors and take over the building.
right. The whole HAL 9000 thing.
Yeah. So how does a non-programmer, a regular manager, interact with an agentic system on, like, a Tuesday morning?
Well, it generally manifests as large language models, LLMs, acting as highly integrated analytics co-pilots. Let's frame it with a really realistic scenario.
Okay, hit me.
Imagine you are a frontline supply chain manager for a major manufacturer. In the past, if a sudden port strike occurred in logistics and you wanted to know the financial impact, you had to submit a formal ticket to the data science team.
Oh man, the ticketing system.
Right. You'd wait 2 weeks, and they would return a highly technical statistical report that you might only, half understand.
Totally.
But today, the agentic LLM deeply understands the specific business context, the underlying semantic data models, and the strict enterprise governance rules.
Wait, let's pause on that phrase, semantic data models. What does that actually mean in this context? Because it sounds like the AI is just guessing based on words.
It's a good question. A semantic data model is essentially the Rosetta Stone between human business language and raw database architecture.
Okay.
So when you say Q3 inventory in plain English, the semantic model maps those English words directly to a dozen specific tables and columns in a cloud database. Things like tab location and SKU count 09.
Oh, I see.
It understands the relationships between the data points. So when that port strike happens, you simply open your dashboard and ask the copilot, in plain English, how does this strike affect our regional inventory, and what is the most cost-effective rerouting strategy?
And the AI doesn't just spit out a generic Wikipedia article. It actually calculates the company's specific logistics.
It dynamically generates the complex SQL queries required to pull the data. It runs the optimization algorithms, calculates the transportation costs, and then it explains the results to you in plain language.
That is wild.
It democratizes the data completely. You do not need a specialized master's degree in data science to access the raw power of the enterprise data warehouse anymore.
Right.
And furthermore, the agentic part means the platform actively intervenes. If the system spots a data quality discrepancy while pulling that report, or notices a security policy violation, it resolves it autonomously, logging the action for minimal human oversight later.
Okay, but here's where this entire landscape gets incredibly paradoxical, though. Based on the briefing, we have this sci-fi level AI. It can fly a damaged drone home autonomously. It can write complex database queries based on conversational English. But if you look at the day-to-day life of a data professional working in the trenches right now in
Oh,
2026,
I know where you're going with this.
80% of their operational time is still spent doing what is essentially digital janitorial work, data wrangling.
Yes. It's the great defining irony of the artificial intelligence age. 80% of the operational time, the budget, and the mental energy is still dedicated purely to cleaning and structuring data.
Why is that still a bottleneck? I mean, if the AI is so brilliant at writing SQL and rerouting global supply chains, why can't it just look at a messy spreadsheet and figure out what the human meant?
Because an AI is completely fundamentally dependent on pristine, unambiguous input. A machine learning algorithm, no matter how many billions of parameters it has, is at its core just a pattern recognition engine. It lacks human common sense. So the proliferation of these advanced algorithms has actually dramatically increased the demand for flawless data architectures, rather than eliminating it.
I want to try an analogy here to see if I'm grasping the mechanics of this. It sounds like having a 3 Michelin-star chef in your kitchen.
Okay, I like it.
The chef, the AI has flawless technique. They know exactly how to execute a complex recipe. But before they start cooking, someone snuck into the pantry and swapped the labels on the sugar and the salt.
Oh, wow.
And someone else put a rotten onion in the vegetable bin. The chef is working so fast, trusting the labels implicitly, that they just throw it all in the pot. The technique was mathematically perfect, but the meal is catastrophically ruined.
That captures the danger perfectly. The algorithm trusts the data it is fed. Think about where modern enterprise data actually originates.
It's a mess.
It's an incredibly fragmented, chaotic ecosystem. It is not a neat, organized spreadsheet. You have high-speed, Internet of Things, IoT sensors on a manufacturing line pinging thousands of times a second.
Okay.
You have legacy relational databases that were built in the late 1990s and patched together over decades. You have unstructured text from customer service chat logs, real-time video feeds, legacy paper logs.
And in the past, human technicians would manually extract this, which caused massive latency and human error.
Right. And if you feed that chaotic, unnormalized data into an advanced neural network, the AI doesn't inherently know it's messy. It assumes the data represents the ground truth.
So it just runs with it.
Exactly. It will confidently hallucinate. It will find false mathematical correlations that do not actually exist in the physical world. It will amplify historical biases hidden in the old data, and it will generate business recommendations that are delivered with absolute mathematical confidence, but are catastrophically wrong and highly damaging to the organization.
So it's the old programming adage of garbage in, garbage out, but scaled up to 1,000,000 miles an hour, and executing trades or logistical moves before a human can even catch it.
Yes. Without meticulous data wrangling, which involves normalizing the data structures, transforming conflicting formats, mathematically imputing missing values, the AI is not just useless, it is actively dangerous.
Right.
This is why highly technical database management and data wrangling skills are still the most critical, yet frequently underestimated, components of the applied data mining lifecycle. You simply cannot skip the agonizingly hard work of building robust, clean data pipes just because the visualization dashboard looks pretty.
So we have these massive agentic systems, and they absolutely require pristine data to function. Processing all of that clean data through complex neural networks requires massive computational power.
Massive.
Which brings us to the elephant in the room that every executive is terrified of right now, the cost.
Oh yes, the bill.
Running millions of live telemetry points through cloud algorithms cannot be cheap. Let me pose a hypothetical. A mid-level manager runs a highly complex generative AI query over the weekend to test some new market theory. Come Monday morning, who handles the fallout when the cloud computing bill hits $50,000?
You've just described a scenario that has kept CEOs awake at night for the last 3 years. The computational costs are extraordinarily expensive. As AI has scaled from pilot programs to enterprise-wide deployment, computational and cloud storage costs have surged proportionally.
So how are they dealing with it?
This sheer financial terror has given rise to a relatively new but absolutely essential discipline in the corporate world called FinOps.
Cloud financial operations.
Correct. And the data from the briefing, looking from 2025 to 2026, shows a staggering shift in corporate governance. AI FinOps enterprise adoption jumped from 63% to 98% in a single year.
Wait, 98%? That figure is wild. That means literally everyone who is anyone in the corporate space realized almost simultaneously, we are bleeding money if we don't put a loosh on this.
The fear of what the industry calls bill shock is very real and very justified. When an organization utilizes consumption-based billing models on massive data platforms like Snowflake or Databricks, they aren't paying a flat monthly fee for a server.
It's all variable.
Exactly. Every single query, every data transformation, every model training session costs a fraction of the cent. But when agentic AI is running millions of those microtransactions an hour, those fractions compound into millions of dollars very quickly.
So does FinOps step in to just tell the engineering team to stop running queries? Like, shut off the cloud, we're broke.
No, not at all. You can't stifle innovation to save a few dollars. The primary driving mandate of FinOps is not purely cost-cutting. It is about measuring the specific return on investment, the ROI, of every single data mining model in production.
Okay, so making sure it's actually worth it.
Exactly. The FinOps practitioner has to translate the computational bits and bytes into measurable bottom-line business value. They utilize platforms that track what are called virtual currency units or tokens, which allows them to execute incredibly granular cost allocation.
So instead of a generic, massive IT bill, they can go to a specific department and say, hey, the AI model your marketing team built to generate new customer personas cost us $40,000 in compute cycles this month, but we can track that it only generated $12,000 in attributed new sales.
Exactly. The model is operating at a massive loss. Optimize it or turn it off.
That is brilliant.
It replaces unpredictable, catastrophic bill shock with forecasted, justifiable, and accountable expenses. And this urgent strategic necessity has caused a massive power shift in the corporate hierarchy. This is where the landscape looks very different today.
Right, and who is actually wielding that power? Because traditionally, anything with the word finance in it rolls up to the chief financial officer, the CFO.
That is the assumption, but the reality of 2026 is fundamentally different. 78% of FinOps teams now report directly to the chief technology officer or the chief information officer.
Wow.
They bypass the traditional finance department entirely.
That is fascinating. The CFO is basically logged out of the biggest line item expense on the ledger.
Why? Because to successfully govern the variable, elastic spend associated with generative models and machine learning pipelines, you need deep technical expertise.
Right.
A traditional accountant looks at a massive AWS or Azure bill and just sees a terrifyingly large number in a spreadsheet. They don't know how to reduce it without breaking the company's technology.
They just say, make it smaller.
Exactly. But a FinOps professional, usually someone with a strong information systems background, looks at that exact same bill and sees token-based pricing structures, model inference scaling inefficiencies, and hardware amortization schedules.
They speak the language.
They understand the technology driving the cost.
Yeah.
Their job is to guarantee that technological innovation never outpaces financial sustainability.
Man, that makes so much sense. Okay, so we've established the massive scale, the computational power, and the terrifying costs of this 2026 data reality. But let's shift gears and talk about the physical geography.
Yes, let's.
Because all of this abstract cloud computing and agentic AI actually has to touch the ground somewhere. The servers exist in a physical space. And the epicenter of this revolution isn't the traditional tech meccas. It isn't Silicon Valley. It isn't New York or Austin. It is the Dallas-Fort Worth Metroplex, DFW.
The shift has been swift and decisive.
Well,
DFW has officially been recognized as the preeminent technology hub in North America for 2026.
The #1 spot, surpassing San Francisco, surpassing Washington, D.C. I have to ask about the mechanics of that. Why DFW? I mean, I know the BBQ is exceptional and the real estate is comparatively cheaper, but there has to be a hard technical reason why the biggest AI systems in the world are migrating to North Texas.
It's a compounding alignment of several strategic factors.
Right.
First, you certainly have massive economic strength and a highly favorable regulatory climate. Texas has no state income tax, which acts as a massive accelerant for corporate relocations and talent acquisition.
Yeah.
But technically speaking, the foundation of this dominance is infrastructure. Specifically, massive historical investments in data centers and what we call dark fiber.
Let's define dark fiber for a moment because it sounds like a plot device from a sci-fi thriller.
I know, it's a wonderfully dramatic term for a very practical asset. Dark fiber simply refers to unused optical fiber infrastructure.
Okay.
During the telecom boom of previous decades, companies laid thousands of miles of subterranean glass fiber optic cables, far exceeding the bandwidth demands of the time. This fiber was laid, but not actively transmitting light, hence it was dark.
Ah, I get it.
And DFW possesses a staggering concentration of this infrastructure, anticipating future bandwidth needs that no one could have fully predicted back then.
So it's essentially like a city planner building a massive 10-lane underground highway system 20 years before the population booms.
Hmm.
And now that the population, or in this case, the massive data requirement of AI has arrived, DFW is the only city without a catastrophic traffic jam.
That is the exact dynamic. Now that agentic AI requires moving petabytes of telemetry data with single-digit millisecond latency, that dormant dark fiber is an unparalleled competitive advantage.
It's a huge head start.
It is. You combine that data pipeline with the robust Texas power grid required to cool massive server farms, and you have the perfect environment for an AI hub. This infrastructure advantage has fueled a tech sector growth rate in DFW of 4.4%, which significantly outpaces the national average.
Wow.
The Metroplex now supports a dedicated tech workforce of over 329,300 professionals.
But the research briefing highlights a massive caveat to that growth. There is a desperate, acute talent gap, correct?
Acute is almost an understatement. The rapid expansion of physical infrastructure and corporate relocations has created a massive shortfall in human capital. Companies are desperate for what the industry specifically calls data-savvy managers.
So not just pure coders.
No, they do not just need isolated people who can write Python code. They need hybrid professionals who possess both the deep technical capability to architect machine learning pipelines and the strategic business acumen to oversee their deployment and financial ROI.
They need people who speak both languages fluently. The language of advanced mathematics and the language of corporate money.
Yes, and because the supply of that specific hybrid talent is currently so low, major global corporations headquartered in DFW spanning retail, aviation, and defense are aggressively, almost ruthlessly, competing for this talent pool.
I want to look closely at some of these corporations because the applied use cases happening right now in the DFW backyard are just mind-blowing. Let's start with retail. 7-Eleven, headquartered right in Irving, Texas.
A perfect example of shifting perceptions. When the average consumer thinks of 7-Eleven, they invariably think of Slurpees, hot dogs, and convenience.
Right. Late-night snacks.
Exactly. They do not realize that the corporation is a globally recognized pioneer in enterprise-scale machine learning and sensor fusion.
They operate over 84,000 stores worldwide. How are they deploying AI at that physical scale?
They are heavily invested in cashierless retail and real-time microscopic inventory intelligence. They have developed and deployed patented technology that essentially constructs a real-time, high-fidelity digital replica of their physical convenience stores.
A completely digital twin of the physical store environment.
Yes. When a customer walks through the front door, turnstiles or overhead spatial sensors assign them a unique anonymized identification number. From that moment, synchronized in-store camera networks and ceiling-mounted LiDAR track their interactions within the physical space down to the millimeter.
Okay, I need to push back on this point right here because the privacy implications here feel massive. Tracking my physical interactions down to the millimeter, that is just straight up surveillance.
I know, it sounds intense.
Anonymized metadata is a very polite PR term, but if an AI knows exactly how long I lingered in front of the candy aisle and exactly how my hand moved to grab a specific brand of chips, aren't consumers pushing back against this? How does a major retailer balance that level of intense surveillance with consumer comfort?
It is the defining ethical and business risk of cashierless retail, without a doubt. If the consumer feels actively surveilled in a punitive way, the friction destroys the business model.
Nobody wants to shop in a panopticon.
Exactly. So 7-Eleven's strategy relies on ensuring the tracking is entirely focused on the inventory rather than the biometric identity of the human. The system doesn't know your name or recognize your face. It knows that Object ID 45 picked up a specific CU.
Okay, that's a little better.
And the real magic is in the sensor fusion. They use automated machine learning shelf sensors. The physical shelves themselves are equipped with hypersensitive weight scales. They predict what you put in your cart based on the gram weight change on the shelf.
So the shelf literally feels the weight of a single soda bottle being removed.
Yes. And then an overarching artificial intelligence system takes that shelf weight data and validates it against the millimeter tracking video feed to flag any visual or physical discrepancies.
For example, like the weight sensor on the shelf indicates 2 hot dogs were removed, but the spatial camera network only registered the customer's hand grasping one item.
Exactly. The AI flags the anomaly and resolves it, ensuring absolute billing accuracy without a human checkout line.
That is insane.
The technological infrastructure required to process this sensor fusion in real time across thousands of stores is staggering. And to maintain their edge, they use internal AI gateways to continuously run aggressive A/B tests. They are actively comparing their own proprietary in-house machine learning models against commercial off-the-shelf algorithms from tech giants like Google and Amazon.
So they're essentially setting up a real-time drag race between their own retail AI and Google's AI using live store data to see which algorithm is more accurate at predicting human behavior.
That's exactly right. And beyond the cashierless experience, they are deploying robust classification algorithms across their massive historical transactional databases to detect anomalous behavior.
Like fraud.
Yes, they monitor vendor payment irregularities, and crucially, they use data mining to protect their digital loyalty programs, which represent tens of millions of dollars in annual value from sophisticated, automated fraud rings.
That is a whole different level of retail. Let's take that scale of a convenience store, though, and multiply it by 1,000. Let's talk about physical infrastructure. DFW International Airport.
I flew through there recently, and unless you work there, you really forget how massive of an operation it is.
Oh, it is less of an airport and more of a sovereign logistical entity. It operates essentially as an independent city, complete with its own zip code and emergency services.
That's great.
It handles nearly 90 million passengers a year.
The raw scale listed in the briefing is wild. 172 million square feet of pavement, 133 aircraft bridges, over 474 miles of subterranean water and telecommunications infrastructure. Managing physical, degrading assets on that unprecedented scale is an immense logistical and financial challenge. To sustain their aggressive growth and execute a massive $3.7 billion capital improvement program, DFW Airport has fully embraced the concept of predictive maintenance driven by AI.
Okay.
They utilize an enterprise-scale digital twin platform provided by a tech company called Willow.
So just like 7-Eleven built a digital twin of a small store, DFW has constructed a digital twin of an entire city-sized airport.
Yes, but with vastly more complex telemetry. They took previously siloed, isolated building management systems, HVAC, electrical grids, water pressure, and unified them into a single, cohesive data environment.
Unifying all those old systems sounds like a nightmare.
Oh, it's a huge task. This platform currently integrates over 171,000 distinct physical assets. We're talking about everything from the massive moving walkways and jet bridges down to the individual subterranean pressurized water pipes.
And they are pulling data from all of this in real time.
The Willow system continuously ingests and analyzes more than 124,000 live telemetry data points using hundreds of thousands of active machine learning instances running concurrently.
I always try to bring this back to the FinOps perspective. What is the actual tangible ROI on that? Why spend the millions of dollars and hundreds of thousands of hours required to set up sensors on 171,000 assets?
The ROI lies in the profound difference between preventive maintenance and predictive maintenance. By applying advanced data mining algorithms to this massive stream of sensor data, DFW detects incredibly subtle microdeviations in asset performance long before catastrophic, visible failures occur.
Let me see if I follow. Under the old system, a jet bridge breaks down completely at 2:00 p.m. on a Tuesday during the Thanksgiving holiday rush.
Which is a disaster.
Right. This causes a massive cascading domino effect of delayed flights, missed connections, and furious passengers, costing airlines millions in compensation and fuel.
That is the reactive nightmare. Under the digital twin model, the AI notes an incredibly faint vibration anomaly in a specific hydraulic motor on a Friday afternoon, an anomaly a human inspector would never, ever notice.
Wow.
The system flags it, calculates the time to failure probability, and autonomously schedules a predictive maintenance intervention during the off-peak night hours. The repair happens seamlessly at 3 a.m., preventing any disruption to passenger flow whatsoever.
That's incredible.
The strategic financial objective here is massive. DFW is targeting a 20 to 25% reduction in total operational maintenance costs by the year 2030.
That equates to hundreds of millions of dollars saved just by letting the math tell you when something is going to break. It's incredible. Let's bring the geography back to the initial hook we started the show with, though. The drone navigating the fuel crisis.
Right, the autonomous rerouting.
That wasn't just a hypothetical scenario we invented. That specific technology is being developed right here in DFW too with Lockheed Martin.
Yes. Lockheed Martin maintains massive aerospace headquarters in Grand Prairie and Fort Worth. They are heavily leveraging agentic AI for the next generation of defense architecture. They recently inaugurated a rapid fielding center in Dallas.
What's the goal there?
The specific mandate of this center is to use data simulation and AI to compress hardware prototype development cycles from years down to mere months.
Because the reality of modern global defense is that if it takes your engineers 10 years to design, test, and build a drone, the underlying technology is completely obsolete by the time it actually flies.
The development cycle must outpace the threat evolution. And their legendary Skunkworks division conducts these highly sophisticated live demonstrations of AI-driven mission contingency management. This is the Stalker XE Block 25 unmanned aerial vehicle that inspired our opening scenario.
So when that unexpected fuel pressure drop or environmental contingency happens mid-flight over hostile territory,
The onboard and ground-based AI systems ingest the sensor telemetry instantly. The algorithms evaluate multi-dimensional variables that a human couldn't possibly process in real-time weather patterns, battery degradation, proximity of friendly assets, radar threats.
it's just too much math for a human brain.
Exactly. It generates the replan options, autonomously reassigns the tasks to preserve the mission objective, and commands the compromised unit home. It has applied data mining, saving multi-million-dollar physical assets and mission objectives in fractions of a second.
And we see a very similar philosophy applied to consumer manufacturing over at Toyota's North American headquarters in Plano, right?
The underlying logic is identical, though the application is different. Toyota employs hundreds of data scientists executing a massive multi-year digital transformation. They are actively breaking down historical data silos.
How so?
Well, they're taking the live connected vehicle behavior data streaming from cars currently on the highway and fusing it with the microscopic manufacturing telemetry data coming from the robotics on the assembly line.
So wait, they are cross-referencing the wear and tear data of a car with 50,000 miles on it in, like, Ohio, with the exact calibration data of the robotic arm that installed the suspension 2 years ago in the factory.
Precisely. To catch systemic defects at the root, before the next batch of cars moves down the assembly line, it is root cause analysis accelerated by machine learning.
Okay, this is where I need to take a step back.
Mm-hmm.
We have these massive, incredibly powerful, slightly terrifying AI systems running our international airports, our retail infrastructure, our cars, and our autonomous defense drones.
That's a lot to take in.
Which begs a very serious question. How do organizations like Toyota or Lockheed or DFW Airport prevent these massive systems from hallucinating? If an AI can hallucinate a legal brief, it can certainly hallucinate a false pattern in a jet engine sensor and do something catastrophic. What is the guardrail?
That is arguably the most critical question in modern information systems governance. You cannot just lock brilliant data scientists in a room, give them petabytes of data, and let them play in a sandbox.
Right.
You need a formalized, rigorous framework to ensure the output aligns with reality. The most prominent industry standard methodology used to prevent these disasters is called Prescriptive.
Prescriptive, the cross-industry standard process for data mining.
Yes, and understanding this framework is non-negotiable. This is exactly what academic blueprints, like the programs at Tarleton State University's Dr. Sam Pack College of Business, anchor their entire curriculum to.
Like the Master of Science in Information Systems program.
Exactly. Or even the undergraduate paths like the BBA in Management Information Systems or the BS in Computer Information Systems for the more technical route. And they also have the BAS in Information Technology for folks finishing their degrees.
Right.
But especially in those advanced MSIS core courses like BCIS 5316, Applied Database Management, and BANA 5310, business applied data mining the professors deeply embed this rigorous six-phase Prescriptive life cycle into the student experience. It becomes the lens through which every technical problem is viewed.
I want to walk through this Prescriptive life cycle. Because if you are listening to this deep dive and you want to understand how a multi-million-dollar AI project is actually managed from inception to deployment without crashing the company, this is the secret sauce. How does the process begin?
It begins entirely removed from the technology.
Really?
Yes. The paramount first phase is business understanding. Before a single line of Python code is written, before a database is spun up, the project leaders must translate a broad, often vague corporate objective into a precise, mathematically solvable data mining problem.
Give me an example of translating a vague objective into a data problem.
Sure. A CEO might say, "We are losing 10% of our streaming subscribers every month. Fix it." That is a business problem, but it's not a data problem yet.
Okay, so how do you bridge that gap?
The business understanding phase translates that into, We need to build a predictive classification model that identifies which specific behavioral markers, like decreased login frequency or skipping intro credits, indicate a 90% probability of a user canceling their subscription within the next 14 days, so we can intervene with a targeted discount.
Ah, I see.
Students in these MSIS programs are repeatedly taught a hard truth. An algorithm is entirely worthless if it doesn't solve a defined business problem with a measurable financial payoff.
I love that. Doing complex math without a financial imperative isn't business. It's just an expensive academic hobby.
Exactly.
So once you have the business problem defined, you move to the data.
The second phase is data understanding. This involves the initial extraction and exploratory analysis of the raw data sets you think might solve the problem. You are essentially conducting a reality check.
Looking for red flags.
Right. You're looking for severe limitations, documenting missing variables, and identifying the overall data quality. You might realize the data you need to solve the problem simply wasn't collected.
Which leads directly into the phase we discussed earlier, data preparation. The 80% janitorial work.
Mirroring the harsh industry reality. This phase utilizes applied database management techniques to meticulously clean, merge, and normalize the disparate data structures.
This is where the Michelin star chef is organizing the pantry, ensuring the salt is salt, and handling the missing values.
Exactly, either by dropping incomplete records or imputing them statistically.
And once the pantry is clean, we finally get to cook. The modeling phase.
This is where the mathematical magic happens. This is the application of the specific algorithms, ranging from simple linear regressions to highly complex deep neural networks. The data scientists select the appropriate techniques and optimize the hyperparameters, which are essentially the tuning dials of the algorithm, to achieve the absolute best mathematical fit for the prepared dataset.
But fitting the data perfectly in the lab doesn't mean it works in the real world, which brings us to the safeguard phase. Evaluation.
This is arguably the most important phase to prevent catastrophic deployment disasters. It requires rigorous, objective backtesting.
How does that work?
You test the predictive model against a holdout dataset, historical data, that the algorithm was entirely hidden from during the training phase. You need to ensure the model actually addresses the initial business parameters, and you must verify that it hasn't simply memorized the training data, a flaw known as overfitting to historical noise.
So you make sure the AI actually learned the underlying pattern rather than just memorizing the answers to the test.
Precisely.
And if it passes evaluation, you reach the final step. Deployment.
Integrating the validated algorithm into live operational business systems. This ensures the insights generate automated real-time actions, like the drone rerouting or the DFW airport scheduling a repair. By anchoring their entire pedagogy to crisp DM, programs like Tarleton State ensure their graduates aren't just building theoretical models in a vacuum. They are architecting robust end-to-end solutions that guarantee functional, safe enterprise deployment.
I want to dive much deeper into that modeling phase because the research briefing highlights 3 specific, highly distinct methodologies taught in these advanced programs that are actively driving the DFW economy right now. Let's start with supervised learning, specifically the methodology known as classification. Explain how supervised learning actually works.
Classification is critical, and the defining characteristic of supervised learning is that it relies entirely on historical data sets that contain explicitly labeled examples.
Okay, so humans are involved here.
Yes, the human has already provided the answer key. We call this the ground truth. You use this massive labeled data set to train the algorithm to accurately categorize new, unseen, ambiguous data points into predefined discrete classes.
The primary high-stakes example highlighted here is the DFW financial sector using classification to fight credit card fraud. Walk me through the mechanics of that.
Well, modern banking systems use agentic defense networks that evaluate hundreds of concurrent variables during a single swipe of a credit card, all within milliseconds.
What kind of variables are we talking about? Like, what is it looking at?
The system looks at the exact transaction amount down to the cent. It evaluates the merchant category code. It pings real-time geolocation data. It analyzes the historical spending rhythm of the user. Does this person usually buy coffee at 7 a.m. in Dallas? Or electronics at 3 a.m. in London.
Right.
And it checks the device IP address fingerprint. To process all of this instantly, they use advanced classification models. A prominent technique is gradient boosting. utilizing algorithms like Cat Boost.
Let's break down gradient boosting, because it sounds incredibly complex.
It is elegant in its complexity. Instead of building one massive, unwieldy decision tree to evaluate the transaction, gradient boosting constructs an ensemble of hundreds of shallow, relatively weak decision trees sequentially.
Okay.
Each new tree is specifically trained to correct the mathematical errors made by the previous tree.
So it's essentially building thousands of tiny if-then scenarios simultaneously, and they all vote on the outcome?
Yes. And within 10 milliseconds, the ensemble calculates an aggregate probability score and instantly flags the transaction as either fraudulent or legitimate.
But here is the massive catch, and this is exactly where the human governance of CRISC-DM comes in, the mathematical equilibrium of evaluation. Because the AI is just providing a probability score, the human has to decide what to do with it.
This equilibrium is a core competency developed in programs like the MSIS. The manager has to balance the true positive rate against the true negative rate.
Let's unpack those terms so we understand the stakes.
A true positive is a victory. It occurs when the system correctly identifies and blocks an actual, malicious, fraudulent transaction. A true negative is also a victory. It occurs when the system correctly ignores a normal, legitimate transaction and authorizes the sale.
Sounds straightforward, maximize both.
Mathematically, you can't. They are on a teeter-totter.
Okay, explain that.
If the bank's risk department sets the model's threshold too aggressively because they are terrified of losing money and want to catch absolutely every single piece of fraud, you inevitably generate excessive false positives. You start declining completely legitimate corporate spending.
Oh, I see. Imagine the CEO of a major corporate client tries to buy a highly important client dinner in London, and your hyper-aggressive algorithm declines his card in front of everyone because the geolocation was anomalous.
Exactly.
You infuriate the client, they pull their massive corporate account, and the bank loses millions in lifetime value.
The aggressive model saved you $100 in fraud but cost you millions in reputation. But if you swing the pendulum the other way and set the threshold too leniently to avoid angering customers,
You get false negatives, actual massive fraud slips through, and the bank hemorrhages money paying out claims.
right? The AI can calculate the probability perfectly, but it takes a human information systems manager, someone who understands the overarching business strategy and client relations, to decide exactly where to draw that line of acceptable risk.
That is a perfect example of human governance. Okay, let's move to the second modeling methodology, unsupervised learning, specifically the technique called clustering. How does this differ from the supervised classification we just talked about?
In stark contrast to classification, clustering is utilized when a dataset entirely lacks pre-existing labels. There is no answer key. There is no ground truth provided by humans.
You just have a massive, terrifying pile of raw data, and you essentially tell the algorithm, figure out the underlying structure of this.
Precisely. The objective of sophisticated clustering algorithms like K-means or DBSCAN, which stands for Density-Based Spatial Clustering of Applications with Noise, is to autonomously discover hidden structures and natural groupings within complex, multidimensional relationships.
Give me a visual of how K-means does that.
While K-means, for example, plots every single data point in a multidimensional space and mathematically calculates the physical distance between them, iteratively grouping them around central points called centroids.
And the dominant DFW use case for this is redefining retail marketing personas.
Yes. Retailers operating in the sprawling, demographically diverse suburbs of North Texas use clustering for hyper-niche marketing. They extract vast amounts of raw transactional history and structure it using a specific framework called RFM.
RFM. Break that down for us.
Recency, frequency, monetary value. How recently a specific customer made a purchase. How often they transact over a given period and their total financial expenditure. The data scientists take millions of these unlabeled customer records and execute clustering algorithms against them.
And what does it output?
The AI mathematically segments the customer base into distinct, high-value personas based purely on empirical purchasing behavior.
This point is absolutely crucial because of what it eliminates. It entirely removes biased, flawed human assumptions from the marketing strategy.
That is the ultimate value. Historically, a human marketing executive might assume, based entirely on outdated demographics, that a certain zip code or age bracket automatically wants a certain product.
They build a campaign based on gut feeling.
Right. But the clustering algorithm completely ignores human assumptions. It only looks at the unfeeling mathematics of behavior. It might reveal that a highly lucrative cluster of customers who frequently buy high-end electronics crosses all traditional demographic lines.
So it changes everything.
It allows retailers to abandon incredibly inefficient mass marketing, stop wasting ad spend, and deliver hyper-personalized offerings to the exact mathematical cluster that will convert.
Which brings us perfectly to the third and final modeling methodology, association rules. This is commonly known as the market basket effect.
This is another incredibly powerful, unsupervised technique. It analyzes the co-occurrence of items within a massive transactional database. It identifies strong, frequently occurring purchasing patterns using specific mathematical metrics known as support, confidence, and lift.
This feels like the old retail adage. If a customer buys a flashlight, they are probably going to buy batteries.
Yes, the logic is identical, but upgraded to an enterprise scale, analyzing millions of distinct SKUs. Utilizing computationally efficient algorithms like FP growth, which builds a highly compressed tree structure of item frequencies to avoid the computational heaviness of older algorithms like a priori retail analysts can process years of transaction logs in minutes.
And they do this locally?
Oh yeah, local electronics hubs and massive big box stores in places like Richardson use this constantly.
They aren't just looking at flashlights. They want to know exactly why certain highly specialized hardware components or specific software packages are consistently purchased together across millions of transactions.
And this resulting data isn't just an interesting factoid. It directly and physically dictates operations. It determines the literal physical layout of the stores, deciding which products are placed on the high-value end cap displays. It drives dynamic pricing optimizations.
And online too, right?
Absolutely. In the digital realm, it forms the architecture of the algorithmic cross-selling recommendation engines on e-commerce platforms.
Right. If the FP growth algorithm calculates that you have a statistically significant 78% probability of buying item B after putting item A in your digital cart, the system is going to aggressively flash item B right in your face, maybe with a 5% discount, right before you check out.
Exactly.
It maximizes the retail yield per square foot, both in the physical aisles and on the digital screen.
Absolutely. It is the invisible architecture of modern retail.
So let's bring all of this highly technical theory back to the listener. What does this all mean for the human being listening to this deep dive right now? We've talked about these incredible autonomous systems running the economy, but how do you, as an individual, actually position yourself to thrive in this 2026 landscape? Because if the AI is doing the heavy lifting of writing the code and the AI is making the complex predictions, what is the role of the human professional?
This raises the most important question about modern career trajectory. The role of the human is to evolve into what the industry calls the business technical translator.
The translator. I like that phrasing. What does it entail?
Purely technical computer science degrees, while incredibly valuable, often produce graduates who excel in isolation. They are brilliant at writing complex Python code or optimizing back-end database queries. But the modern C-suite in 2026 doesn't just need isolated coders in a back room.
No, they need context.
Right. They desperately need hybrid leaders who can bridge the formidable, often fatal communication chasm between the highly technical data science team and executive corporate strategy.
Because let's be honest, the CEO of a Fortune 500 company does not care about the hyperparameter tuning of your DBS scan clustering algorithm. They don't know what that is, and they don't want to know.
Exactly. The CEO cares entirely about how that specific neural network improves supply chain risk, reduces operational overhead, and drives quarterly revenue.
Makes sense.
In academic programs like the MSIS at Tarleton State, by integrating core courses in managing information systems, IT project management, and strategic information systems, are explicitly architected to solve this communication gap. They aim to elevate professionals from tactical, execution-focused roles, like a mid-level systems administrator, into strategic leadership positions. They are training the future IT project managers, directors of analytics, and chief information officers.
And the labor market is aggressively financially validating this specific career path. The data pulled from the Bureau of Labor Statistics in the briefing is wild.
The projections are striking. They are projecting a massive 15% growth in employment for computer and information systems managers from 2024 to 2034. That rate of expansion is classified as much faster than the average for all occupations in the U.S. economy.
The briefing notes that equates to over 101,600 net new leadership positions over the decade and the median wage. It hit $171,200 annually in May 2024.
It places the occupation firmly among the highest compensated management tiers in the entire national economy. The market is paying a massive premium for the translation skill.
Which leads to a massive debate happening right now among job seekers evaluating their educational options to capture those salaries. Formal master's degree versus technical boot camp. I want to play devil's advocate for a
Okay,
sec.
let's hear it.
Are these 6-month technical boot camps a waste of time and money?
No, boot camps are certainly not a waste of time, but it is absolutely critical for a professional to understand the distinct return on investment and the long-term career trajectory that each path offers. A technical coding boot camp typically requires an upfront financial investment of around $14,000 and takes an intensive 3 to 6 months to complete.
And it does successfully get you in the door. The data shows the average starting salary for a bootcamp grad is roughly $70,000 nationwide.
It is a highly viable initial outcome, especially for someone executing a hard career pivot from an unrelated field. However, the data also shows that bootcamp graduates frequently encounter a rigid glass ceiling within enterprise corporate environments a few years into their careers.
Why do they hit that ceiling? If they know of the code, why can't they advance?
Because the training in a bootcamp is intentionally necessarily narrow. It focuses almost entirely on tactical syntax, how to write a specific script in Python to solve a localized problem. It is designed for immediate, ground-level deployment.
They aren't learning the big picture.
Right. A bootcamp generally does not have the bandwidth to cover enterprise data architecture, the underlying mathematical theory of algorithms, cloud financial operations, FinOps, or strategic corporate management.
So they teach you how to type the code perfectly, but they don't teach you how to govern the multi-million-dollar system or how to explain the ROI to the board of directors.
That is the core limitation. Furthermore, in tightening, highly competitive labor markets, enterprise applicant tracking systems, the automated software that scans resumes before a human ever sees them, often systematically filter out bootcamp credentials for leadership roles, heavily favoring candidates holding accredited university degrees.
Meanwhile, if we look at the data for an MSIS graduate, particularly operating in the DFW market, the contrast is staggering.
The current average annual salary for a professional wielding a master's in information systems in the DFW Metroplex is approximately $104,645. And the 75th percentile of earners in that cohort commands compensation packages well over $128,000.
And let's not forget the geographic advantage we discussed earlier. Texas has no state income tax. When you factor that in, that compounding salary premium year over year, decade over decade is massive.
The fundamental differentiator for anyone making this choice is this. A technical bootcamp prepares a worker to write localized scripts and execute tasks. An MSIS program prepares a strategic leader to architect the multi-million-dollar implementation, ensure the ethical governance, and guarantee the financial ROI of those technological systems across the entire enterprise.
It's the difference between being the highly skilled person who swings the hammer on the job site and being the chief architect who designs the skyscraper, balances the budget, and ensures the building doesn't collapse.
That's a very accurate summation. And in a global economy that is rapidly moving toward fully autonomous AI systems writing their own code, you absolutely want to be the architect, not the hammer.
Okay, this has been an incredibly dense, fascinating, and highly practical journey through the modern data landscape. Let's recap how far we've come in this deep dive.
We covered a lot of ground.
We really did. We started with the vivid, high-stakes visual of an agentic AI acting as an autonomous co-pilot, effortlessly handling a complex drone emergency in seconds. We then looked at how that exact same philosophy of agentic AI and sensor fusion is tracking retail behavior down to the gram and the millimeter in DFW and running complex predictive maintenance on subterranean pipes at the airport to save hundreds of millions of dollars.
We examined the absolute necessity of the CRISPR-DM framework. We discussed how that rigorous 6-phase life cycle is the mandatory governance needed to keep the complex mathematics honest, ensuring these powerful models actually solve tangible business problems without hallucinating or causing financial ruin.
And we broke down the profound difference in long-term career trajectory between learning tactical syntax at a coding bootcamp versus becoming a strategic business technical translator with an advanced degree like an MSIS.
For those listeners who are genuinely motivated by this landscape, those who want to take that next strategic step and capitalize on this projected 15% surge in demand for information systems managers, there are some critical time-sensitive realities you need to be aware of.
If someone wants to act on this, what are the immediate next steps?
Using Tarleton State University as our prime example, their Fall 2026 MSIS program within the Dr. Sampak College of Business is designed specifically for working adults. It is structured entirely online to accommodate professionals. Priority registration for these highly sought-after cohorts officially opened on March 27th.
Getting in early means securing your placement in those specialized, high-impact data mining classes before they hit capacity.
Yes, and the absolute final, hard deadline for application submissions and graduate admissions processing is July 15th. I strongly advise prospective students not to delay. Get your undergraduate transcripts requested and your professional references submitted well in advance of that July 15th deadline to ensure smooth processing. It's a strong investment for those looking for flexibility and real-world career prep.
Consider that a very strong, actionable opportunity for your future career trajectory. Also, we don't want the conversation to end here. We want you to actively interact with this complex material. Utilize the Notebook LM platform linked in our show notes.
Yes, definitely use that.
You can use it to ask customized questions about the DFW tech job market, dive deeper into the nuances of the BCIS 5316 database curriculum we discussed, or get tailored advice on navigating your own specific career transition.
Continuous, active dialogue is absolutely essential in a technological field that evolves this rapidly.
So true. Also, don't forget to tune in next week for episode 15 by 2026, Visualizing for the Boardroom. It's going to be a great follow-up to what we talked about today. But before we officially wrap up this deep dive into applied data mining, I want to leave you with one final provocative thought to mull over. We opened the show by talking about the machine autonomously doing the high-stakes work of the human operator. As we look to the horizon of this technology, where does that actually leave us as professionals?
It leaves us in a position of supreme, unprecedented strategic importance. In a world where artificial intelligence is increasingly autonomously capable of building, testing, and executing its own complex data models, the most valuable human skill is no longer simply constructing the machine. The most valuable human skill in 2026 and beyond is having the moral, financial, and strategic wisdom to tell the machine exactly what it needs to optimize for. Are you ready to step up and be the governor of the system, rather than just remaining a replaceable cog inside it?